Okay, hello everyone, and I'm here with you again with the machine and mechanism A subject tutorial problem for the week number 6. And actually, this is a modified copy from the one that I made yesterday. And I just actually changed something with the free body diagrams for these questions. And also here we're going to cover the fourth question that we are having for this sheet. So we start with the question number 1. And the question number 1 was about the woman that sits on the rigid position on her rocking chair by keeping her feet on the bottom at the rank at B. Determine her forward angular acceleration alpha and the frictional force at A necessary to prevent the rocker from slipping. The woman and the rocker have a combined mass of 90 kilograms and radius of gyration about the point G of 0.45 meters. And as you remember, we can calculate the IG value for the chair and the lady by using this kg value squared multiplied by the mass. That's what we're going to do in the first step. Now, going to the analysis of the forces we have on the free body diagram, we can find that at the point A, we're going to have the normal force and the friction force that prevent the chair from sliding. At the G point, we're going to have the weight that's going downward. In the kinetic diagram, we're going to have the accelerations, normal and tangential, at the point G, when the link AG is going to be rotating around the point A, because once again, this is a no-slipping case. So we're going to have that link that will rotate in this direction, because that's how the movement is going to be forward. Okay, so it's going to be rotate to the counterclockwise direction. And also we're going to have the force due to this, well, of course, this one is going to be 0 because the lady is on rigid position. That means she's on rest. So the omega is going to be equal to 0, while the tangential one is going to be equal to the r multiplied by the alpha. That we don't know what the alpha is. Also, we're going to have the IG alpha that causing the moment in the kinetic motion. Now, for using some of the dimensions we have here, and that's once again we're going to be explained on next page, but it's going to be nice if we are going to do it right here. So you can see that this height is 0.48 meters and this one is 0.2 meters. If I'm going to connect a line between these two points, I'm going to have an angle here of theta, and I can find what the length of the R GA, which is going to be 0.52, and we're going to show you how we find that. Actually, it's a resultant of the two sides of the triangle, the upright triangle, and the angle can be found by calculating the tangent of this angle, which is equal to 0.2 divided by 0.48. So the solution steps that given to us by the textbook is going to be by applying the free body diagram and the kinetic diagram, and then we're going to find the forces in the free body diagram should be equal to the forces in the kinetic diagram for the x and the y directions. Also, we are going to calculate the moment around the point A in the free body diagram, and this should be equal to the moments around the point A in the kinetic diagram. So the result later should be the alpha is 4.15 radian per second square. The FA is 179 Newton, and the NA is going to be 808 Newton. So we start first with define that the bottom rung is going to be on the arc, where the section of the large circle is going to be moved, so the problems can be treated as a rolling motion without slip. So again, this is our free body diagram. You can see that we're going to have the weight going downward, and we're going to have the two reaction forces at the point A, the vertical and the horizontal one. And we said that the theta and the sides can be calculated later. And also we have the kinetic diagram, where here we're going to have the acceleration tangential, because you said that the normal one is going to be equal to 0. This tangential acceleration is going to be equal to the alpha multiplied by the distance from G to A. This force can be analyzed into two components, which is going to be the horizontal and the vertical, or the X and the Y, which is going to help us and do the analysis for the forces. So this will be the dimension, the direction of these forces is downward and to the left, and that will make them both negative in our calculation. How we calculated that? By using the theta value. So the m multiplied by the ag to the x direction is going to be equal to the m multiplied by the at multiplied by the cosine of the theta, while the y1 is going to be multiplied by the sine of the theta. Also, we're going to have the Ig alpha, which is going to help us to calculate the moment around the point A. So the known value are going to be the mass, the kg value, the omega is equal to 0, and the unknown is going to be the Fa, the Na, and the alpha. So the set of the equation we're going to use in this question is going to be the three that we know. I use the A is force. So the sigma of the forces at the point to the x direction in the free body diagram is going to be equal to the kinetic forces we have in the kinetic diagram. So what we are going to do here, we can find, for example, for the x direction, the Fa is equal to the magx. For the Na minus the W is going to be equal to the magy. For the moment around the A, it's going to be W multiplied by 0.2, and this will be equal to the Ig alpha and multiplied by the MAT, this should be M here, MAT multiplied by that distance, which is 0.52. And thus we are going to be able to find the value for the alpha, then go back to the calculation of the acceleration t, then we can find what the values for the n and the f. So we start first with the calculating of the Ig, which is going to be the mass multiplied by the kg square. So we're going to come with the solution that the Ig is equal to 18.225 kilograms meter square. Now that's what's step number one. Now we need to calculate the RCA, which is the RGA, which is the distance from the point G to the point A. And this can be done by treating the triangle. We're going to have the two sides and find the result of them. This will be the chord of the GA. So this will be mainly equal to 0.52 meters. Now we're going to go with the calculation of the accelerations. So the acceleration in the normal direction is going to be that direction here, that the acceleration normal is going to be equal to the omega square multiplied by the RGA. Because the omega is 0, so the AGN is going to be equal to 0. Now we go to the tangential one is going to be the alpha multiplied by the RGA. And this will give me that the AGT is equal to 0.52 alpha. We're going to assume that it's going to be positive, so the alpha is positive. That's going to mean going to that direction. Okay, and thus the AGT should be positive as well. But you can find later that for the direction of the force is going to be, the force is going to be negative. So we're going to dividing this acceleration into two components, the x and the y. So we can simply do that by multiplying it by the cosine of the theta to go to the x-axis and the sine of the theta to take it to the y-axis. So for the first one, is going to be equal to 0.48 alpha meter per second square. And for the y direction is going to be 0.2 alpha meter per second square. Okay, now we've prepared all the ingredients and we're ready now to apply the equations A, B, and C to find the unknowns, and then we can solve for everything. So we start with the equation for the forces to the x-axis is going to be equal what we have in the free body diagram. They're going to be equal to the kinetic diagram. So we come to the equation that the only components we have in the free body diagram in the x-axis is going to be the Fa here. So the Fa is going to be equal to the mass multiplied by the Agx. So that's the mass multiplied by the Agx, which is going to be negative 0.48 alpha. And then we can define the value for the Fa as a function of the alpha to be equal to negative 43.2 alpha Newton. Now we're going to do the same thing for the y direction. In the y direction, we're going to have the weight negative and the Na positive. That's what we have in the free body diagram. While here we're going to have the negative Magy. So we're going to write down that. And we're going to substitute the values for the weight, which is going to be equal to the mass multiplied by 9.81. And here the mass multiplied by the acceleration to the y direction, and this should be equal to negative 18 alpha. Now we can rearrange the equation, and we find that the NA is equal to the weight minus 18 alpha. So we found the second equation. Now we have two relations, and we're going to use them later to find the value for the F. And for the NA, we just need to find the alpha. So now we go to the third equation that we stated earlier, which is going to be about the moment around the point A. So by applying the moment for the chair and the lady body around the point A, we can find the value for the alpha. Because the kinetic diagram moment is going to contain the alpha twice, while the MA is going to have only the forces and the distance. So if I'm going to clean this one first, okay. So now in the free body diagram, we're going to have this force perpendicular to that distance along to the point A, which is 0.2. So mainly is going to be the W multiplied the 0.2, and this will take the moment to the counterclockwise, so this should be positive. On the other side, we're going to have the M multiplied by the AT multiplied by the distance RG/A, which is 0.52. And this moment was going to be to the counterclockwise, so it should be positive. And the IG alpha is going to be also positive. So I can put these parameters in, and I'm going to come with this equation where it's going to have the two alphas here are unknown. Now, if I'm going to just come with you about the parts, the 90 is the mass, 9.81 is the gravitational acceleration. So I'm going to have the weight multiplied by 0.2, which is that distance. That's what we have in the free body diagram. Here, this is the value for the IG that we calculated multiplied by the alpha. That the mass multiplied by the acceleration tangential multiplied by the distance from the G to A. Okay, so we got all the parameters. And now again to solve for that, and I will find that the value for the alpha is equal to 4.15 radian per second square. If I'm going to apply that in the equation 1, I will find that the Fa is equal to negative 179 Newton. And substitute the alpha in the equation 2, I will find that the Na is going to be equal to 808 Newton, which are compatible results with the answers that we found. Okay, so thank you very much, and we're going to see you in the next